Hey guys! Alright, so today we're going to learn about solving special systems. Okay, and this is from your textbook and it's on page 220. So a system of linear equations can have one solution. Okay, and we have been solving systems that have one solution. Okay, you can have no solution and you can have infinite many solutions. So what does that look like on the graph? Where if you have one solution, your lines are going to intersect at each other. Okay? And we know where they intersect, that is going to be your solution. Okay? So they intersect right there. Okay? They're going to have different slopes. No solution, which means they have no point in common. Okay? No point is going to make both equations true. Okay? They don't have any one point in common. So if you have no solutions, you're going to have parallel lines. So your graph is going to look something like this. Okay, and you can tell, okay, you don't have any point that is common for both of these lines. Okay, and it's just going to keep going on forever. Okay, so it's going to have no solution at all. So you're going to have the same slope, but you're going to have a different y-intercept. Okay, and if you get a graph that looks like this, your answer is going to be no solution. Okay? Or you can have infinite many solutions, and this means there's numerous points that's going to make both equations true. Okay, and when you have this, it's going to be the same line. So when you graph it, it's going to look like you have one line. Okay, you're going to have the same slope and you're going to have the same y-intercept. So as soon as you realize, okay, that it's the same line, you probably don't even have to graph it. You can automatically say, oh, it's one line, so it has infinite many solutions. Okay, no solution, there's no point in common. Infinite many solutions means, okay, all the points they have in common. Okay, that's on this line. Okay, we'll satisfy both lines, both equations. One solution, okay, there's only one point that's going to satisfy both equations, okay, and that's when you're going to have it intersect each other at one point. Okay. So we're going to do some examples. So this first one, step one, put it in y-intercept form. This y is already by itself, so I can go ahead and graph this. And this is going to be, try to get this as perfect as you can. So this next one, first thing I'm going to ask myself, is this in slope-intercept form? Is y completely by itself? And the answer is no, so we have to put it into slope-intercept form. Okay, and when we put an equation to slope-intercept form, we first want to move the x. So the inverse of positive is going to be negative. So I'm left with y equals negative 5x plus 0. Again, since this is plus 0, I don't have to write that. Okay, so it's just y equals negative 5x. Now I can graph it. Okay, my y-intercept is 0, and my slope is negative 5. And this is very close. Okay, but if you look at it, does these two lines have any point in common? Is there any point on that line that's going to make both equations true? Okay, do they intersect? No. Okay, so they do not intersect. They're parallel lines. Okay, they do have the same slope. Okay. So your answer is going to be simply no solution. So anytime you have two parallel lines, you're just going to put no solution. And that's for that one. Okay. So this next one, we're going to do the same. Okay. need to draw my grids right quick. Okay, so let's look at the first one. Okay, y is by itself, so I can go ahead and graph this one. Okay, so let's do this next one. Okay, this time this is not in slope-intercept form. Your y is not by itself, so we have to put it into slope-intercept. Okay, step 1, move x over. This is a negative 8, so I want to do positive 8x on both sides. Don't forget your x. A lot of you love to forget it, and it's buddies with that 8, so you don't want to separate the buddies. Okay, bring your x term outside. This is a positive 4, so it's going to be plus 4. Okay, y is still not by itself, so step 2, divide by the coefficient of y. Okay, so the coefficient again is this 2. I'm going to divide everything by 2. Okay, 8x divided by 2 is going to be 4x, plus 4 divided by 2 is 2. But wait a minute. Is this the same as this? Yes. Okay, so it is the exact same line, so it's just going to be the same line. So this time, okay, there's not one single point, okay, that they intersect. It lays on top of each other. Okay, so that means any of those points that you choose on that line is going to satisfy both of these equations, which happens to be the same line. Okay, so for this one, okay, you're not going to give me a coordinate pair. You're not going to put no solutions. Okay, instead, you're going to write infinite many solutions. Okay. So when you do your assignment today, okay, you're either going to give me a coordinate pair, okay, you're going to say no solution, and remember that's parallel lines, or you're going to say infinite many solutions, and that's when you have the same line. So there's 3 different cases that you can have. Okay, so please just be careful, look at it. Okay, I have some practice problems that you can pause this video and work out. Okay, and let me know if you have any questions. And then when you come back, we will go over the answers. Okay, I hope you've completed it. So this is the answers for the practice problems. Okay, this one, when you graph it, you're going to have no solutions. Okay, there's not one point in common. And then down here, you had to change some things up. Okay, but it is the same exact line, so you're going to have infinite many solutions. Okay, again, please let me know if you have any questions, and have fun on your assignment today.